Hi, all. So we are still solving logarithm equations, and as you can see here, we have a logarithm equation that has two terms that have a logarithm. And when you have this, what you need to do is use your logarithm properties to get your logarithms to one term. Okay, both of these are base 2 logarithms, which makes them like terms, I guess you can say. And since we have a addition sign in between the two logarithms, we can use our product rule to bring those together to one term. So I can say this is logarithm base 2, and I will have my t plus 2 times my t minus 2, and then this will equal 5. So I have just used the product rule to bring these together to one term. At this point, you have a logarithm, one logarithm term on the right, I'm sorry, on the left, and we can take this logarithm equation and change it to exponential form. So it'll be 2 to the 5th. So we'll have 2 to the 5th. Sorry, my pen's going crazy here. 2 to the 5th equals t plus 2 times t minus 2. Then now I'm just solving this equation with algebra. So I can multiply the right side. That'll be t squared minus 4 when it's multiplied and simplified. 2 to the 5th is 32, and so I can subtract 32 from both sides. So I'll have a 0 on the left, and negative 4 minus 32 will be minus 36, or negative 36. At this point, I can factor the right side to t plus 6, t minus 6. I can then set each factor equal to 0, and I'll have t equals negative 6 and t equals positive 6. Now here's an equation where it is very important to check your solutions. When you go back into your original equation, so let me just rewrite it here. When I put a negative 6 in for t, actually in both spots here, I'm going to have a negative outcome. I'll have logarithm of negative 6 plus 2, and this is a negative 4. And remember, we've discussed this in a previous video. You need the inside of your logarithm to be positive. So it has to be greater than 0. Same thing will happen over here. You'll put a negative 6 in minus 2, and you'll get a negative 8. So in both of these situations, you have a negative outcome. It just takes one spot to mess up the whole thing. But here it is happening multiple times. This means that we must disregard the negative 6. Okay. If we continue to check, we'll put the 6 in. So you'll have a logarithm of 8. So I forgot to write my base 2 here. Actually, I forgot to write my base 2 a lot of places here, didn't I? Okay, so I'll have a logarithm base 2 of 8 plus logarithm base 2 of 4. Okay, we can then think of our product rule here. Okay, so we can say this is logarithm base 2 of 8 times 4, which is 32. And logarithm base 2 of 32 is 5. And so when we use the positive 6, it checks. Okay, the negative 6, however, did not check. So we only have one valid solution for this logarithm.